Thank you very much. Let me please first share my screen for you all to share my view. Okay, I hope everyone sees what I see. Hello everyone, my name is Phibos Iliopoulos and I am a network consultant for comBOX multi-WAN services, which is a pioneer in bandwidth aggregation and WAN optimization solution. Together with the General Managing Director, Mr. Antonios Haidemenos, I would like to welcome you to this special webinar that was organized together with our new partners in SecureOne in order to introduce our virtual Leased-Line, an affordable MPLS and Leased-Line alternative solution. After a brief introduction, our manager and I will showcase the various applications of our bonding services, and at the end of our presentation, we will also have a brief demonstration of our service. After our presentation, we would like to have a thorough discussion during which we would like to hear the specific network challenges you face and also listen to your particular requirements according to your industry and market strategical targets. I would kindly ask you to keep any question you may have for the end of the presentation. We will make sure there is enough time to answer everything in detail at the end. We will also like to inform you that we will be recording this talk for future reference and training purposes, and we will make this talk also available for you to download. So, then let's please start by introducing the basic characteristics of our service. The comBOX Virtual Leased-Line is a world-leading software-defined WAN and internet bonding solution. It consists of the customer premise equipment, a cloud-based state-of-the-art internet bonding technology, and a real-time monitoring and management platform. Our technology bonds any mix of satellite, cellular, and fixed-line internet into a fully optimized, unbreakable single connection, which is far superior than the aggregated individual legs. Our system architecture enables the creation of secure wide area networks by linking multiple comBOX CPEs using a hub and spoke topology. So our service actually deals with all the typical connectivity issues that result in unreliable internet connections and creates unbreakable internet by bonding any mix of cellular cards, fixed line, as well as satellite connections through a single static IP address. It improves speed, latency, and security with complete resilience, allows the client to build their own private network by linking multiple comBOX CPEs, monitors, and manages connectivity in real time. It eliminates internet downtime and provides corporate quality internet at any location. More importantly, we offer our service at market-leading pricing. To the best of our knowledge, this is currently the most affordable non-leased line solution on a global scale. Now let's have a look at the functional characteristics of our service. The comBOX Virtual Line solution provides a secure and breakable internet connection by merging a variety of internet sources, including fixed line, cellular, SIM cards, and satellite connections. Each of these connections are referred to as a leg. When one or more of these legs are aggregated, the term is referred to as bonding. The comBOX VLL solution also provides a transparent failover mechanism to ensure resilience in case any of the available connections fail. The solution maintains all active sessions by rerouting data packets to the healthy connections, guaranteeing unbreakable internet connectivity. Each comBOX customer premises equipment can be securely connected to any other comBOX CPE using end-to-end encryption over the bonded connection. This functionality enables the creation of a secure wide area network when multiple comBOX CPEs are connected to each other. This creates a single network across global locations, which facilitates secure data exchange, for example, between the different branches of a company. Actually, companies with remote branches are only one subcategory of businesses that can benefit from our services. The comBOX bonding solution can be a solution to a very wide range of businesses, which allows you to target practically any company with increased internet demands in the Malaysian market as a potential client. For example, businesses which have no fixed line internet connectivity, or companies that need to ensure that their branches are always safely and stably connected online. While another common use case are companies who need enhanced internet resilience for their business services, so to say, always-on service provision. Other potential clients are, of course, those who are in an area of low-speed telecom infrastructure and need to boost their bandwidth. A very common case in fast-developing countries like Malaysia, where the infrastructure development cannot cover the rapidly increasing network demands. Finally, potential clients are also businesses that need a reliable temporary internet solution fast and effectively, regardless of their local connectivity provision, such as event organizers or once-off TV and video streaming productions. Our distinguished clients range from small and medium-sized enterprises to multinational enterprises, including McDonald's, Amazon, MediaMarkt, the NATO Alliance, well-known law firms, international banks, hotel franchises, and Eutelsat, #1 satellite operator in Europe. From TV streaming to cruise ships and satellite services, the comBOX technology can facilitate a huge range of different applications and market demands. It is quite safe to say that our technology is designed to practically deal with any connectivity issue of any business, regardless of their magnitude, their location, or their existing infrastructure. So the comBOX network appliance is placed between the customer's LAN infrastructure and any available WAN connections, acting as an internet gateway. The WAN connections can be any fixed line modems or routers, cellular SIMs connections, or satellites. The implemented algorithm distributes data traffic at the packet level to the available WAN connections. The comBOX VLL network server is a fully managed cloud server within our global private cloud infrastructure. For each new comBOX deployment, we provision a new dedicated virtual server located in the nearest data center to the customer premises. The network server or bandwidth aggregation server is essentially the other end of the circuit where multiple WAN connections are transformed into a single one. So let's have a look at some samples of the employed CPE. This unit, the BR100, is equipped with an integrated LTE modem, so you can bind a SIM card connection. It also provides 4 Ethernet ports. One is reserved for LAN, and the other ones are reserved for satellite or fixed connections. The max bonded throughput is 250 megabits, and if you need to connect more cellular connections, you can use up to 3 external LTE modules. So in total, 2 external, 1 internal module. Here we can see how the internal module is mounted on the motherboard. In order to place your own SIM card, you need to unscrew the bottom part of the cage and then simply place your SIM in the slot. What is important to remember is that to implement SIM cards, these should not be configured to operate with PIN codes. And now for the BR315S model. And now this is our best-selling box. The BR315S router is the best performing small factor comBOX network appliance and can support all of the available comBOX service bundles. It comes with 6 physical network interfaces and supports the bandwidth aggregation up to 5 WAN links. The total WAN aggregated throughput can reach up to 1 gigabits, covering even the most demanding speed requirements. It offers 1 LAN port and up to 5 LAN ports to fix external connections like satellite, and additionally 2 USB ports to connect up to 2 external LTE modules. The 1 gigabit speed makes it suitable for most commercial and industrial implementations. This box can be also mounted in a rack and connected serially to more comBOXes using the additional layers we provide together with the purchase. So this is the external LTE module that is compatible both with the BR100 and the BR315. You can connect this to both appliances. It has one SIM slot that is easily accessible where you can insert your SIM card. And as we mentioned before, when implementing this device, please remember you should insert an unlocked SIM card containing no PIN code. We sell globally, and on this map, you can have a look at the different locations we provide our service around the world. Our service is accessed by the nearest local data center in the proximity of each business in order to assure the shortest possible latency and highest connectivity performance. As you can see, we acquired resources in most continents around the world, forming our own global user network, while we are currently expanding rapidly also in Africa and South America. Specifically for Malaysia, your regional internet breakout point would be Singapore. While we expand, our fundamental policy is to always reinvest in new resources to guarantee a high-performance resource network closer to where quality connections are needed most. If you have customers with branches in many different countries and locations, our service would be each time accessed by the nearest available data center. Our strategy is simple. The more you will expand your client base, the more we will be expanding our network to bring our resources closer to them. The high performance of this technology offered in such a competitive price will be a game changer for the Malaysian network market. We strongly believe in the capacities of development of the Malaysian market, and we intend to boost it by covering the existing demand gap. Now let's have a look at how we can facilitate the installation of our service and what kind of technological features optimize our service according to each customer's different demands. Essentially, the big advantage of our service is that it integrates to all the different existing network architecture without having to modify any existing equipment or infrastructure of the client, while at the same time, we offer centralized service monitoring. Let's have a brief look at these features. So our service provides end-to-end bidirectional quality of service. The comBOX VLL services offer reliable end-to-end quality of service, multiple wall connections in a simplified manner. The bonding is achieved through smart or transparent IP failover. This enables to survive WAN connections outages without a change in public IP address, allowing for session continuity. If we compare this to the common load balancing solution, we see that in load balancing, whenever there is a failover, the open sections are interrupted and data is lost, which is actually catastrophic for a number of applications. Because our bonding solution offers one single throughput combining different input connections on the same output line, our transparent failover allows that all active sessions are not interrupted, avoiding data loss and assuring the continuity of our clients' services. The comBOX VLL technology enables real-time data compression on the network layer to accelerate data transfers for uncompressed data. Send and receive data is automatically compressed in real time to save bandwidth and further improve WAN performance. The next feature is the optimized bandwidth aggregation, according to which the comBOX VLL services use our proprietary traffic distribution algorithm to aggregate the bandwidth of multiple WAN connections and create a virtual fat pipe whose speed is equal to the sum of the speeds of the individual WAN connections used. Another important feature of our software is TCP acceleration. The comBOX VLL technology incorporates a transparent performance-enhancing proxy to accelerate TCP traffic over high latency and congested links. One of the most frequent applications for this service are satellite links. The acceleration is achieved by splitting TCP sessions and introducing an optimized TCP stack, as well as advanced congestion control algorithms. Finally, by implementing transparent routing, the comBOX network appliance offers the ability of transparent routing via the bridged mode functionality. It enables the transparent operation of comBOX network appliance by forwarding the provided public IP addresses to the relevant internal network. This way, the network administration can be performed locally on the client's current network infrastructure. Our service has been designed to implement state-of-the-art standard security practices. The communication of the equipment with the server is authenticated with security protocols, and moreover, we offer the possibility of end-to-end encryption between branches, always guaranteeing safe access to the equipment. Our security comprises traffic authentication at the node level. The CPE and the aggregation server authenticate each other using 4096-bit RSA keys and the TLS protocol along with a strong encryption cipher site. The keys are generated, managed, and signed by a private PKI, avoiding the problems of trusting third-party CAs, presenting a far smaller attack surface by eliminating the complex certificate chain validation risks commonly linked with SSL security. All the above ensure no attacker can modify or forge bonded traffic between the CPE and aggregation server. DDoS protection can be enabled on a comBOX VLL service instance to add 10 gigabits of mitigation capacity per VLL instance and safeguard all attached IP addresses. comBOX VLL services support DNS filtering upon customer request to filter all DNS requests based on specific filters, including lists of known malicious domains, torrent trackers, porn sites, and more. The system has the ability to perform SSL IP VPN encryption for hub and spoke VPNs using 4096-bit RSA keys with SAJ256 certificates, TLS, and Diffie-Hellman key exchange with elliptic curves. Industry standard SSL protects the appliance from unauthorized control, while the CLI that could be accessed with SSAs is equipped with protective functions by using access control lists. All services integrated in the router can be precisely configured in regards to how these services are accessible via which interfaces and IP networks. By its nature, the technology is highly secure. The packet-level distribution algorithm spreads traffic across multiple internet connections, and even if an attacker manages to capture one of our individual internet connections, only a small part of your entire traffic is visible. So even though this is not a standardized security feature, it clearly provides a strong additional level of security. Now, indicatively, we can have a look at how our GUI interface looks. This is where you can set quality of service rules, priority classes, hierarchize them, and so on. I don't want to spend too much time here because you will have a chance to look at this in detail during the demo session with Antonios later. But again, just indicatively, here is another view about configuring LTE connections. Here our clients can define VPN and set the primary or a backup leg and also define their usage limits. And here we have another view of the monitor platform, which shows the quality graphs for two connected legs. Our monitoring offers aggregated view of all the licensed equipment in one single view. You can view qualitative measures of each leg. For example, the yellow and blue lines show the download and upload packet loss respectively. And these online plots help us monitor the service centrally and facilitate administrators with a quick overview of the quality of the connections. This online monitoring helps them diagnose possible problems and proceed to the troubleshooting as soon as possible. In the same monitor, the client receives alerts about restarts, unconnected legs, unreachable equipment, and so on. These alerts can be also forwarded to the emails of the administrators as well to bring an issue to their attention as soon as possible. So by this, I would like to introduce our General Managing Director, Antonios Haidemenos. He will take over from here to explain common scenario and specific use cases of our technology. And also, he will be performing a short demonstration of the comBOX bonding solution. Thank you very much for your attention. Antonios, the virtual podium, so to say, is all yours. I will now answer my screen so we can share your own view.
Phibos, you can continue with sharing your screen. So I will switch once we proceed with the demo.
Very well, very well.
So please help me with the next slides. Thank you. Hi all, I'm Antonios Haidemenos. I'm a co-founder and managing director of Protonics, the vendor of comBOX multi-WAN services. We have developed the solution, as Phibos mentioned, since 2008, and we are the pioneers of bandwidth aggregation and WAN optimization virtualization solutions. Together, we'll go through a few case studies that are indicative of the potential of our solution and what connectivity issues we can resolve, especially for big customers and the enterprise. But you can also see some case studies referring to smaller projects or even projects on the IoT sector. As a first case study here, we have Amazon, which is one of our major customers. Amazon maintains various warehouses around the globe with advanced connectivity requirements. Amazon's main concern is high availability on the connectivity, reliable performance, and also advanced flexibility. In most cases, the solution was deployed using solely cellular connections, given that most warehouses were located in areas outside urban areas with limited telecom infrastructure. So Amazon requires a reliable, high-performing connectivity solution to connect these warehouses with their headquarters. To deliver the solution, we had to bond multiple LTE 5G connections in order to achieve high throughput. In all cases, we managed to deliver bonded connections ranging from 100 to 500 megabits, depending on the site location and cellular coverage, while the Amazon minimum requirement was 100 megabits at each site. Amazon also required the solution to be carrier neutral, meaning that we couldn't rely on a single ISP network in order to minimize the possibility of service downtime due to malfunction on a single carrier network. In order to deliver that, we provided the solution with our own M2M global SIM cards. These SIM cards support at least 2 carriers per site to enable greater flexibility, reliability, and control, while improving the performance significantly and minimizing service downtime. Amazon also had a specific requirement regarding the IP address allocation. Their policy required all sites to connect with an static IP address belonging to a /30 subnet. And for larger sites, Amazon requires the assignment of an additional /29 subnet backrouted to the main IP address in order to support the multiple in-house hosted services within the network. The comBOX devices are configured in bridge mode, allowing the configuration of these subnets directly on the WAN ports of the Edge firewall routers. This solution had to be universal on a global scale, given that Amazon maintains similar warehouses across the globe in European Union, UK, USA, Canada, Middle East, and India. We had to adapt our processes accordingly, so every region was covered by the same processes, and in terms of SIM card provisioning and the whole VLL service provisioning process. And we offered Amazon, and it was a main requirement, a plug-and-play solution. The solution that is offered to Amazon is fully managed, plug-and-play, by bonding multiple cellular connections in all required locations. All Amazon has to do, their engineers, they have to connect our portable travel case, CPE, which we'll have a chance to show you in following this presentation. They have to just connect the power plug to a power source and the LAN cable to the Edge router at its warehouse, and the solution is up and running. We have been, Amazon has been our customer for the last 3 years, and we consider the project a huge success given that as we go on, more sites are deployed and more regions actually adopt this solution. Another important case study is with Zenith Bank in Nigeria. Zenith Bank is one of the major banks in Nigeria, and they maintain a huge number of branches. Our solution has been deployed in 400 branches across Nigeria. And this project, actually, the main requirement was to be able to bond private MPLS connections with public internet connections in order to get advanced resilience and also use their point-to-point connectivity infrastructure. In order to provide that, we had to host the bandwidth aggregation servers within the bank's headquarters. So the bank provided the required cloud server infrastructure where we provisioned the bandwidth aggregation servers. This catered both for security compliance of the bank, and also it allowed the visibility of the private point-to-point IP connections with our servers. In most branches, they bonded both MPLS and public internet connections. And in most cases, they used an LTE as a public internet connection for failover. We also created, the solution was deployed with encrypted connections between the branches, and we deployed the hub and spoke VPN among all branches that used our solution. One of the main requirements of the bank was the ability to communicate via voice over IP. In order to get the best possible user experience with no gaps and no downtime on the VoIP communication, we deployed the solution configured with a specific QoS class for VoIP traffic, and we enabled at this class the redundant mode feature to ensure that VoIP communication runs smoothly with no packet loss and the lowest possible jitter and latency. Actually, the redundant mode, what it does, we duplicate the traffic and we transmit it concurrently, the same data packets over multiple links. This way, the information is always delivered by the fastest path. And we minimize, actually, we eliminate packet loss following this approach and also minimize jitter. And again, it was offered as a plug-and-play solution. All CPEs were pre-configured and shipped to each bank remote branch, ready to be deployed by connecting them on their established infrastructure. In the next slide, I'm going to show you the basic topology of this project, just to understand the main requirement and how we delivered this. As you can see, there are three types of branches. The branch X is a branch that it is connected to the bank's data center headquarters via two point-to-point links. Initially, before our solution was deployed in the bank used two point-to-point MPLS connections from different ISPs. One was the primary, and the second one was the failover connection. By deploying our solution, they managed to get both connections working concurrently. So they increased the throughput, the connectivity throughput of the branch, and also increased the service uptime through the transparent failover mechanism, where all sessions are maintained without any loss. The second type of branch is a branch which also has one or two MPLS point-to-point connections and public internet connections. In most cases, it was a wireless LTE connection. And the third option for the bank was to for branches that had no access to MPLS connections, and they were mostly in remote areas. So they had to connect solely by using LTE networks. So we deliver the solution by bonding 2 or more LTE connections at these branches. All our network servers, as you can see in this graph, were placed within the bank's data center. The bank offered the cloud infrastructure where they provided access to our engineers to install and provision the virtual Leased-Line virtual machines that are required for the solution to work. Let's go to the next slide. The Aldemari resorts are one of the biggest, actually, hotels in Greece. Their main requirement is to offer high-speed and uninterrupted internet connectivity to their guests. Their hotels, actually, during the summer, which is the peak season, have on average 500 guests, and maybe on the larger hotels even more. Their hotels are actually in locations covered by limited terrestrial connectivity. For example, the fixed lines connections that can be delivered to these hotels, these areas, cannot exceed 50 megabits. So in order to deliver the requirement to a solution based on the requirement, we had to bond a mix of fixed lines, cellular, and Starlink connections. So the solution was able to reach ultra high speed, ranging from 500 megabits to 1 gigabit, and even in areas with limited telecom infrastructure. We also provided advanced quality of service configuration in order to reserve part of the internet capacity for events and conferences, which was one of their main requirements, and also prioritize real-time protocols such as VoIP. Another feature that is quite important for hotels and generally any type of organization that offers free, public access points, wireless access points, so they have a lot of users within the network, is the stochastic fairness queuing. This is a specific feature which is used to share the bandwidth equally among multiple users, improving overall network performance and reducing the likelihood of network congestion or slowdowns. We also apply DNS filtering to their network by redirecting the DNS request to our DNS filter. So we restricted access to torrent, pornographic content, and non-malicious websites and applications. We also, this was also required to meet local legal requirements. And the hotel administrators can monitor all hotels' connections centrally through our cloud service monitor. Let's go to the next slide, please. This is a case study that shows how the solution can be deployed on mobile vessels, such as cruise ships or even yachts. We have several deployments in sea yachts, especially the big ones. We can offer high-speed and uninterrupted connectivity at the sea, and this is what Sea Cloud Cruise Ships was their main goal. In order to provide that, we had to use LTE or 5G connections, so we could get, by bonding multiple connections, in most cases in these cruise ships, we bonded 4 to 5 LTE or 5G connections, and we managed, by bonding these connections, to get really high throughput while traveling on the sea. there are gaps on the LTE coverage while you travel on the sea. So in order to fill these gaps, we also deployed satellite connectivity in the solution. The satellite connections that were deployed were Ka-sat, offering full coverage, and these connections were configured as failover connections in order to cover the connectivity gaps when LTE networks were not reachable. This setup offers the lowest possible operational cost, as all traffic is routed via the connections with a lower cost first. The solution is universal, so all sea vessels can deploy the same solution regardless of their location, the available ISP networks, and they can have even static IP addresses, uniform static IP addresses for at all their vessels, in order to have remote access to their ship's CCTV, and also remote troubleshoot the ship's IT infrastructure. And again, we also deployed DNS filtering, same as the hotel, as the Aldemar resorts, in order to filter guest access to specific sites and applications. This is a military implementation. NATO is the biggest military alliance in the world. The past couple of years, they created new camps in Eastern Europe, where they needed uninterrupted connectivity for both their operation needs and for their military personnel welfare. Each NATO camp in Eastern Europe utilizes our state-of-the-art bonding technology to bond a variety of diverse access technologies per site to offer the required resilience. All NATO sites that use our solution bond one Starlink, one LTE, and one microwave connection, and they achieve more than 500 megabit bonded throughput and no service downtime. Again, NATO had advanced requirements regarding the IP allocation, similar to Amazon, although they required the /29 public IP subnet at all camps in order to support multiple VPN implementations and also access to multiple in-house hosted services. The customer also deployed their own VPNs. They had to manage the encryption themselves. So all the traffic that goes through our solution is already encrypted by IPsec protocol within their own routers. What we did for them in terms of security was to provide advanced DDoS protection mechanism. The DDoS protection mechanism safeguards all the attached IPv4 addresses from distributed denial of service attacks. Based on the current deployments, this mechanism mitigates on average 8 attacks per month per site. And most of these attacks are initiated by China and Russia controlled botnets. The solution also, as we mentioned, it's carrier neutral by integrating multiple access technologies and multiple ISPs. So even if one ISP fails or part of the ISP connections fail, the connectivity will be maintained. And also DNS filtering is applied in this case, although NATO had to provide their own access list, which were loaded to our DNS filter in order to restrict access based on NATO policy. And the last the case that I'm going to show you, which is one of the newest industries that we approach, is the IoT. Rockwool is the world leader in insulation materials and maintains huge warehouses where forklifts move merchandise based on telematic application running on Android tablets. Forklifts actually are moving within these warehouses in a continuous basis, and they get signals from the telematic applications, so they know where to deliver each of the merchandise. And these telematic applications, the main requirement is to be always on. So even 1 minute or 2 minutes downtime can cause a huge issue to their operations. Oracle chose comBOX VLL to eliminate service downtime in areas not covered by the Wi-Fi hotspots by using LTE as a failover connection. One of the main challenges for this project, and generally for the IoT projects, is that the space they have to place equipment is very limited. So we had to provide an ultra small factor CPE, and also we had to make sure that the deployment was waterproof, was protected by harsh environmental conditions. So the solution for this solution, we customized the CPE. We chose, actually we deployed a really small device that was placed within a Q-spot antenna, which offers IP67 ingress protection. And the CPE is equipped with one LTE module and one Wi-Fi module. So we can have 2 legs, one from cellular connectivity and one from for Wi-Fi connectivity. The same solution also is deployed on a global scale. Oracle maintains warehouses in multiple locations around the world with similar requirements. So they have the solution had to be able to be provided to all locations. And the solution is portable, and we provide the CPE along with 16,000 milliampere hours battery pack, which allows the CPE to run for several hours without an external power source. One of their main issues was that every time the forklift stops its engine, their connectivity infrastructure was stopped working and they had to reboot. With our solution, this is not required. So the CPE is not rebooted every time the forklift stops its engine. So as you can understand, our solution can be fully customized based on specific project requirements. Similar solution we're currently running for autonomy robots. It's a company in India who produces last mile delivery robots. These robots are equipped with video cameras, streaming online video 24 hours per day to their operators. So they require a bonded LTE connection to pass this traffic without any gaps when there is limited coverage on a specific carrier. So it's a new area. We are really trying to find new projects. Most of these projects have a huge volume. For example, the Rockwell IoT project involves the implementation of 3,000 installations on the forklifts, and the autonomy robots, their forecast, because currently we're running demo for them, the forecast is like within the next 2 years they will deploy around 10,000 units. So it's an area of huge interest for us. Thank you all for watching this presentation. We also would like to thank our partners, SecureOne, for getting this webinar live. And we hope we manage to showcase our product and potential use cases successfully. Now, I would like to show you a bit of how the solution works, the environment. We'll try to be really, this presentation will try to be really short in order to have some time for questions and a general discussion. So I'm gonna switch. I'm gonna share my screen now to access the central monitor and show you a few things. For everybody who is interested for a thorough presentation on this environment, we can arrange another webinar dedicated to this. So give me one moment to share my screen.
Antonios, thank you very much. Let me also jump in and say thank you to the SecureOne people who helped organize this. You can already share, feel free to share your questions in our chat or send them directly to SecureOne as Chu suggests. Adonis, let's try to keep this a bit short and then hopefully have more time to answer to each one individual question.
Yeah, so if you can all see my screen, here is the central monitor. This is the dashboard. Here we can see all the units that are under our account. So for example, each company who has their own clients can see their own units listed in this dashboard. I'm going to show you the most important stuff here. It's you can, by clicking on the host name of each CPE, you can go to the dashboard screen where you can see traffic statistics. You can choose the period for which you want to see these statistics. Let's say it's the last week. You can also see latency. How's the latency? This latency actually is the latency between the CPE and the network server. And on the below graph here, you can see each of the available connection legs. You can navigate by using these arrows. Here you can see actually quality statistics. This is the most important stuff. Download and upload packet loss. You can see by the yellow and blue line. So the packet loss, as long as these lines are below 0.15%, the connections appear to be working without any issue. Let's go back. Here we can also see the issues or history of the issues for a specific unit by choosing the period that we want to see the issues. For the last 6 months, we can see sample issues here. The device has been restarted, leg 2 went offline, unit is unreachable. All these issues actually can also appear to your email address in order to try to troubleshoot any potential issues with both the hardware, power issues of the devices, problem with the ISP connections, and so on. And let's go really quick to access the CPE. So let me access the CPE. This is the dashboard of the CPE. We can see here it's a demo CPE. We have 2 connections to bonded. One connection offers 200 megabits download speed and 20 megabits upload, and the second connections offers 100 megabit download speed and 10 megabits upload. Here is the real-time charts, so we can see. We can open this tab to see how the traffic in real time. The VLL, the top chart here, shows the bonded connection, and the 2 smaller charts here, you can see how the traffic is split to the available legs. I'm gonna run a speed test now to show you how the traffic is aggregated. So I'm gonna switch the tab. Give me 1 second. As you can see, one line offers around 200 megabits download speed, the second line 100 megabits, and here we get the aggregated throughput, both lines. Now, first we measure download traffic, and once the download test finishes, we're gonna see how the upload traffic is also bonded. As you can see, we have 20 megabits here, upload from the first connection, 10 megabits from the second, and 30 megabits, the aggregated speed on the bonded connection. Once this speed test finishes, we'll see these results here as well. So as you can see, we've got the max download speed, mean download speed, and max upload and mean upload speed, respectively. Through these tabs, we can configure, for example, the LAN tab, if it's gonna perform NAT, the CP, or it's gonna be bridge mode. If we choose bridge mode, these IP addresses should be configured on the edge firewall router on the customer infrastructure. If NAT mode is selected, this comBOX CP acts as the firewall edge router of the customer. So we can also enable the DHCP server. We can indicate if we're going to use the DNS server that is integrated on the device, or we have a custom DNS, internal DNS we need to use. Here we can actually configure the WAN legs. We can use DHCP client to get the IP address from the ISP modems automatically. Or set static IP addresses. We can also, by clicking the gear icon, we can see more options. We can enable or disable bonding. By disabling bonding, each connection that is not enabled in the bonding, it can only be used in policy-based routing scenarios. So it mostly this feature is if we disable bonding is mostly in cases where we don't want to use specific connections due to traffic caps. Probably there is also an option to limit usage of any connections based on limit to specific cap. Let's say 30 gigabytes for this connection. The billing cycle resets every first of the month, or whatever we choose here. So once this limit is reached, the connection will stop routing any data. We can also indicate if it's a primary or a backup leg. If we set the backup leg, we can also set the backup priority if we have multiple backup connections. In case we set the same priority on these backup connections, these connections will be bonded, and they will start routing traffic if all primary connections fail. And there's an advanced feature that applies to primary connections that you can actually specify to use a specific connection only for specific traffic classes if you have configured the QoS system accordingly. So, for example, if you have a connection with traffic caps and you don't want to use it for downloading bulk traffic, for example, downloading files, but you want to use it in the bounded connection to aid to provide more speed, for example, for video streaming application or something that is business critical, you can choose this connection to be used only with specific QoS classes. The advanced tab, you can set port forwarding rules. It's pretty straightforward. Static routing rules, the same applies. And here is the QoS system. You can create priority class based on your demands. You can allocate the bandwidth ratio to each class. You can choose redundant mode. Redundant mode actually, when it's activated, it transmits for all the traffic that belongs to a specific class is transmitted in redundancy to minimize packet loss and jitter. You can classify traffic using these rules here. You can classify by DSCP. This is a common case when the solution is delivered in bridge mode. So all the classification takes place either on the application level or on the edge firewall of the customer. So what we need to know is the DSCP flag that is set on the classification that takes place on the third-party appliance, in order to respect the same classification in our system. We can also classify traffic based on protocol, local IP subnet, local port range, remote IP subnet, or remote port range. It's pretty straightforward, and it's pretty easy to use. Most of our customers don't have any issue deploying their own classification. And the policy-based routing is an option. For example, if you have specific requirements to route traffic via a specific leg, or via legacy load balancing, or through a priority list. So you can identify the traffic that needs to be routed via, let's say, the one priority list. What is a one priority list? You can define this priority list here. The built-in priority list indicates that all traffic will be routed first via the VLL connection, the bonded connection. And then if the VLL connection is not available, for example, the device has lost communication with the server, then it will fall back to the second, the red connection, and then to the blue connection. These are labels we have set for the available connection legs on this device. You can set your own labels as required. And you can create new list, give a name to these lists, as many lists as you need, and you can set your own priority. So for example, if we use this list for specific traffic, all traffic will go through the red connection first. If the red connection is unavailable, it will fall back to the blue connection and then the VLL connection. So it's pretty configurable. You can configure any rules you need for policy-based routing implementations. And the administration tab, you can set if you need to specify a location for the CPE for your reference. Here you can set how, if for the backup connection legs, because in many cases they come with traffic caps, you may not need to monitor these connections really frequently. So you can set to monitor these connections every 12 hours, for example, if it's Inmarsat connections with high cost. You can also reboot, shut down the unit from here, change the administration path with your password. And here you can activate the product using a product activation key that we provide to you. So we send you the license key in a file, and you choose the file from here, and you press the activate product button to have the product activated. Here you can see if the service is online, the user that is connected, currently connected to the GUI. That's all for now. I'm gonna stop this presentation, and will be available for your questions and whatever you need to discuss.
A big thank you also to everyone from my part. I have to apologize a bit for the duration. The planned duration was a bit shorter, but it's our first meetup, so we would like to brainstorm you even more if we had the chance. Still stuck here, and we will now be very happy to take any comments, any feedback, any questions you might have. And even if you don't have a question, we would like to listen at your own requests and your own demands. What you mostly come against when you face your customers' problems, connectivity issues. We also stopped recording. I would like to inform everybody, so no need to feel shy.